Good morning, everyone. My name is Manny Calero. I'm a solutions architect here at ZEDEDA. I've been in the industry over 20 years, 24, 25 years, both on the operations side, building stuff, and also on the sales side. I cut my teeth in Juniper Network, supporting tier one service providers in mobility. I spent some time at Microsoft Azure in their what they call the Global Black Belt Networking team. Spent a couple of stints in different Silicon Valley startups here, and one of them being Aviatrix. So the number 70,000, keep that in mind. We'll come back to it. And the case study that I'm going to present is one of our biggest customers. It's the second largest auto manufacturer in the world, and they're building about 8 million cars, 8 million vehicles per year. They have another 100 million vehicles on the road, and they're servicing tens of millions over thousands of sites every year. And part of that process is the software and image upgrades of those cars. And in the last few years, as we've known, the advent of EVs coming in, that software on the vehicles has become more complex. It's doing a lot more, and it's also grown exponentially in size. And not only that, the software has to be secure. The integrity has to be guaranteed. So there's a unique value to that software for each car. And of course, regulation is keeping a very, very close eye on what's happening. So specifically, UNECE R155, section 724 and 725, explicitly address the software delivery, but not just the software delivery and the software, but the supply chain of that and how that software gets on the cars. So the biggest problem and the crux of the entire use case is you cannot service your cars, you cannot sell them. And that's what they're having to contend with, and that's what we've been helping them with for quite a few years now, and we're deep in that production process. So what challenges were they faced with? 70,000 dealerships, service centers, and manufacturing facilities. Mainly, we're targeting the service centers and dealerships, and we're working towards those other bits. One of the biggest challenges, of course, because of the compliance and regulation, is security, not just at the software layer, but at the physical layer of those components.
Manny, just a question on this. So what are you installing and where are you installing it?
So we are basically helping them deliver that software to the edge through our platform. So we are going to be managing the workloads that the software is going to be, where the software is being processed. And when I mentioned unique before, what happens is every car has a unique image or software that has to be loaded in that car. Those images are massive and they have to be transferred, okay? So what we're basically delivering is the ability for them to do that at the edge. So they can spin up the workloads, process the software at the edge, and then basically take care of just the diffs instead of having to transfer these massive amounts of data into every dealership.
So each vehicle has the computer in it,
Yes.
And that's installed at the manufacturing facility where the base software is installed, what you're saying. And then you have the dealerships and the service centers, which then have the ability to be able to update that software. Is that right?
Exactly. Okay. That's exactly right. It's a classic CDN use case. Yep. Security, very important because of compliance. And then, of course, they're having to contend with legacy infrastructure. So they have all of these requirements coming in. The exponential growth of these images need to be processed at the edge. And the legacy infrastructure that's in place in most locations, right, poses a risk to that in the business, which is the ability to take those images and process them at the edge, which is what we're working towards. And of course, and I think this is a lesson learned from COVID, and I think a lot of, not just this one, but a lot of customers that I talk to bring in, vendor lock-in. Why? Well, supply chain, right? When during COVID, I can't tell you how many customers mentioned the fact that they had a single hardware manufacturer and no ability to get hardware. So we're seeing the diversification of that. This was a challenge that they wanted to address through this process. So what did we do? How did we help them solve this problem? Number one is scale, and not just in the number of sites and connections and clusters, but the way our platform is designed is specifically designed to handle large deployments and handle them as a fleet, right? Imagine if you were to have a platform where you're managing 70,000 endpoints and your configuration is single click every single time. You have to be able to handle it as a fleet and as a kind of an umbrella of deployments, maybe by region, maybe by different states. So the ability to split that up. And then, of course, as Maxi mentioned, our founders from the inception of ZEDEDA were focused on security, focused on physical security. How do you handle that? And our ability to leverage things like TPM and secure and guarantee the integrity of the endpoint, which actually falls back to that UNECE R155 compliance that needs to happen, is very important and why we were selected to do this. Again, so vendor lock-in, we are software agnostic. We will run on pretty much any x86 or ARM-based processor. So that allows them to be flexible in the platforms that they select, and they can have multiple hardware vendors to deploy their solution. And if anything happens again with supply chain, at least they have some diversification there to mitigate that.
So Manny, where are the golden images created and stored?
The golden images are created obviously at the manufacturer. The diffs and the images that are constructed are actually done at the edge because it has multiple pieces. And then what their Kubernetes clusters are doing with different pods is actually constructing those images, but they don't have to pull the entire image now. Now they can just construct with diffs and be able to put that on their car. So it's like I said, it's a classic CDN at the edge, store your data.
And this is all managed via your SaaS platform?
Yes, correct.
A question about the platform support. You mentioned x86 and ARM. Just a curiosity, is RISC entering the conversation anywhere?
I know that in the past that we have supported RISC. We just don't see that. We don't see it that often. Yeah. But yeah, RISC is actually, I didn't say it, but we do support RISC. What would happen is you bring your hardware, we take a look at it, get it certified, validated, and get it up and running. And then, of course, legacy infrastructure. We're a SaaS solution. We're dynamic. We scale. We're designed to scale, handle fleets of endpoints, whether they're at an oil gas platform or sitting in a retail store. We're very flexible in that sense. Remote management, and we're flexible because we can take legacy applications that are in place, and for example, virtual machines. Right, a lot of folks are moving into more cloud native designs where Kubernetes pods, but they still have some legacy applications that need to run at that edge. We can run virtual machines, we can run containers, we can run Kubernetes as well.
And Manny, can you only install software from the actual manufacturer, or can you also install third-party software?
At the dealerships, yeah, at the dealership.
We support both, is the short answer. So I mentioned we have a global marketplace, right? And in there are commercial and open source software solutions. Each customer also gets a private marketplace. And this is where they can bring in, for example, their legacy automobile applications, or maybe a third-party solution that's not in our marketplace. Mm-hmm. So we support all types of different scenarios to allow them to bring in either third-party software from our marketplace or third party.
So some manufacturers have their own GPS systems, others use TomTom, whatever it is, and it doesn't make any difference. You can install whatever.
Correct.
I think we're getting caught on overloading image here.
Yep.
That the image that ZEDEDA is managing is the image that's going in the virtual machine. Mm. ZEDEDA is not directly managing the image that's going out to the car, because their platform's not on the car. So the actual car vendor, the car manufacturer, is managing that supply chain to get onto the car. ZEDEDA's providing an enabling
the infrastructure to be able to manage it, deploy it.
Yeah.
So then in this use case, then the idea is that the box the box you're putting the software on resides in an auto dealer,
Correct.
right?
That is
And so you're saying, okay, if I need to do distribution to my network of 10,000 automobile dealerships globally, I'm going to send a box with ZEDEDA virtualization on it to each of my dealerships and then manage that remotely as a fleet of solutions
Correct.
across that entire system. And that management is done in the cloud through a SaaS platform that you.
That is exactly right.
Okay.
It will
Whole-
immediately phone home, register, and become a
Right.
trusted endpoint.
So you're saying let's put together a solution where we have cloud-based management of essentially cookie cutter solutions spread throughout my edge device.
Repeatable architectures.
Repeatable
Yeah, that's
architecture.
very important.
Now, what happens if we're not looking for, I mean, is this only for the repeatable architecture at each site, or if you wanted to have different customizations for each site or separate sites?
It's 100% customizable.
Okay.
It's advisable to do repeatable architecture. Just as an engineer, you want to be able to have things that you can repeat. But there are those, off cases where you do have to do.
Right, but you
customization. We can
could,
customize
for instance, say, hey, I have a separate configuration for my U.S. dealership network, my U.S. sites versus my European sites versus my
Absolutely.
EMEA sites or something like that, and
Absolutely.
treat each sort of global region as a fleet.
Yeah, so we have a policy engine and tags that you can sort of say tag, in your example, Europe, right? And then obviously if data locality rules, local rules around operating in Europe would apply to that particular node, even though it's still part of a fleet of these 70,000 different dealerships.
Right.
So we can do customization based on policy in a lot of different ways. But in your example, by geography, sure.
But your ultimately, if I understand it correctly, your real goal is to basically provide fleet management of devices at the edge.
Absolutely.
That have a standardized architecture, standardized software suite that you're installing on those devices at the edge.
That's correct.
Okay.
And then
Where
So-
I'm getting confused right now
Okay.
is I think, and I'm completely in favor of this, but I think you left something out of this diagram for simplicity's sake, which is the hypervisor that, unless you're saying you can quote unquote bare metal Kubernetes onto Eve, I would think that you still have that in there. And so the kind of at dealer or core based management of the applications and so forth is happening within Kubernetes on top of the hypervisor. Because where I got confused is you indicated earlier that it's only within, I think this is what you said, it's only within ZEDEDA Cloud that you are managing the images. You don't get direct access to the box. And then now you're saying these dealers do get direct access to the box, but that's via Kubernetes, right?
That's correct.
That's correct.
Okay.
Through the, yeah, exactly.
Okay, that's
Yeah,
elegant.
and this is
that's
a
elegant
very
and
high level.
interesting. Yeah, well,
very high
but
level.
I just didn't. I didn't want you to accidentally contradict this really helpful resilience and security feature that you described earlier of no direct access to the box. It's not really no direct access to the box in this model, but you're doing it via Kubernetes as opposed to, messing with the hypervisor that's already installed. Okay, great.
Correct. And so this is very high level, but this is
No, I'm all in favor of simpler diagrams.
Yep. Okay.
As long as you can explain for the people with, what were they, stupid questions in the room to ask about it, and you can respond. So we're good.
so at a high level. What we've got is the endpoint, which is running Eve. It's registered with our cloud, and what we're doing is we're service chaining the K3S traffic through a firewall, and the management is happening through their orchestration systems. And we have the ability to, through third-party integrations, to make those API calls directly into their orchestration platform. So we can play a role in the actual orchestration
Sure.
of the K3S workloads through those APIs.
So forgive me if this is repetitive, but this being automotive, is this typically a 2-node cluster or something, or
These are single nodes in most cases. They're I mean, 70,000 systems is expensive, right? So these are running on, in this example, they're running on a single node in the dealership. They're running Everything you see on the slide and a little bit more, actually.
Actually, I think I'm thinking a little too far ahead. Things like automated driving and that sort of thing. You know, I would want some kind of physical
Yes.
backup.
And there are different projects
is-
we're working with on this particular customer that are in car and in manufacturing. The one we're highlighting here is that dealership use case. They ship what the dealership thinks is an appliance, right? Fundamentally, it's this stack, but it's a single node system.
Yep.
Sorry, go ahead, Manny.
Just quickly, so what's next on these projects? So we're already working on phase one. We're well over 15,000 nodes in, and we're finding that the orchestration layer is not keeping up with the load for Kubernetes. So we are doing work at ZEDEDA to take over some of that that orchestration layer for Kubernetes.
Maybe just to double click on that. You know, the reality is most Kubernetes orchestrators were built for the cloud. They're built for a couple thousand node clusters. We have, you know, single node, tens of thousands of individual clusters. So it's a very different scaling mechanology. So we're breaking the orchestrator. The way they're solving it now is they're sharding. So they're running sharded instance, but we're, as Manny mentioned, about 25% of the way there, and they know that's not going to work. So we're working really closely with them to build that scalability piece inside the orchestrator side of the house as well.
Yeah, and they're also looking at other applications that run at the dealership to consolidate into this platform as well, things like OEM and parts and things like that.
So one thing, go back, since you had the slides up there, you have, you know, and this is where you're confusing me again, because now you have in-car diagnostic engine and over-the-air firmware, and I thought we were talking about something that's, your box is sitting in the dealership, not on the car.
Yeah. So these are other projects we're working with. It's a confusing slide, my apologies. The point is, for this particular use case, there's really two things that they're focused on. One is fixing the scalability of their Kubernetes orchestrator, right? Because if they can't update, they have challenges. The second is we wrote dealer infrastructure consolidation. Think of that as bringing more and more applications onto this platform. Think of maybe an inventory platform or something, right? Separately, with this manufacturer, we're working on an in-car solution. It's on this slide. It may have confused you, but it is a separate project we're working on there.
Okay.
It strikes me that what ZEDEDA is doing is providing, it reminds me a lot of HCI. I've been chatting a little about that you are providing a software stack for management of infrastructure and environments, the edge applications. It's I'm going to use P word. I'm starting to hate it. It's a platform for doing that, such that it does. I mean, it could be all kinds of applications. There could be all kinds of localities at a dealer, on the road, whatever it is, network connections, whatever it may be. And there's this sort of single management paradigm for providing. It's an abstraction paradigm, really, for hosting the different parts, microservices or otherwise, of the application, the edge, and the core, and allow them to work together.
Yeah, that's what we're doing. We're providing that bridge from legacy to.
But the key here is it's really built upon standardization and management at scale, right? So it's you're treating all of your edge locations as identical. You want to standardize, do things, and then be able to manage that from a central location as a fleet of devices, right?
I think identical is. I get your point. Like it depends on the application, the locale. Like you're going to identify different environments, stacks, and then manage them as a whole.
Manage as a whole, which it makes a lot of sense when you're talking about something at very large scale. Do you want to think about your environment as having 10,000 separate locations, or do you want to say fundamentally they're all the same? I can change my configuration, push a button, and then that goes out to my 10,000 locations, rather than I have to go for each location and say, go update, go update, go update 10,000 times.
I think
that's the key here.
Yeah, I think we've kind of stumbled into a vertical and an IT market that is ripe for disruption.
Yeah.
Having been in the back of dealerships looking at what they're using for infrastructure, it's kind of like, well, that old Dell micro tower probably needs to go away. That's running my diagnostic tooling for the shop, right?
10-year-old laptops.
10-year-old laptops. It's like, how do I get this stuff up to date?
Yeah, absolutely.
But here you're also looking at, so if you look at the dealership as a near edge and the actual vehicle as a far edge, right? how are you, and what I'm interested in is in-car diagnostic engine. Because how are you going to push it? Are you from the dealership to the vehicle?
Yeah.
If each dealership's got thousands of vehicles.
Yeah, no, so that I would love to take offline, because that's a full conversation in itself. So maybe we can table that one towards the end if you don't mind, because
Okay, the next session.
I want to go through 2 other use cases, and I think it'll help you guys kind of understand the different types of scenarios we can bring in.
I was wondering that, so we're basically bringing standardized tools so we can take that next step later.
Yeah, we can talk
You're
about
bringing
that.
all
later.
standardized tools on at each of the
Yeah.
dealerships at this point, and then there's still another explosion of things.
Vehicles themselves.
Next phase.
Absolutely.
Now at least all the tools.
I did want to make a comment to one of the questions. You know, effectively you said it's just or not just, it's a distributed HCI cloud managed infrastructure, right?
No, I don't think it's HCI. Just it reminds me of HCI platform.
Right,
that- yeah.
HCI like, but the comment there is the deploying 2 or 3 node clusters everywhere at scale is the big thing, and the other thing is that these are going into embedded harsh environments with bad environmentals. We'll cover some of that in the Braille use case, but it's the scale is the problem. The lack of local IT hands-on is a problem. The intermittent connectivity is a problem. The environmental conditions. So it's like we have to do all of the cloud goodness at the edge with limited. You know, there's no locked doors. There's no 100 gig backplane. There's no. So that is the part that makes the problem very hairy versus just delivering.
Right. It's not a data
Yeah.
center.
Let's keep.